Hey everybody, this is Larry. This is me going Q2 of the bi-weekly contest 156, minimum operations to convert all elements to zero. Hit the like button, subscribe button, join me in Discord. Let me know what you think about this one. Honestly, this was the hardest one for me to do during the contest, just because even though it didn't take me that long, but it took a bit of convincing. I mean, I think the proof is the hardest part. The other ones, it just kind of took, even the harder ones, it just took me more effort. And the idea that I would say is that for this problem, and let me actually bring up the drawing things. Right. Hang on. Technology. All right. Yeah, I think this one, the key thing to note is that if you had something like I don't know, 5, 4, 5, 3, 2, or something like that, right? You cannot ever group these two fives together because this will always have some smaller number in between. And once you have a smaller number in between, it doesn't matter. The number, because if you can't get rid of it, this will only go down to 0, and therefore this will never be connected. So that's kind of the first idea, right? And then the second is that, okay, well, in that case, then you always want to take the smallest number. Well, your first move will always be just as long as you can, right? Oops. So long that you get off the page. As long as you can for the entire segment, right? The reason because, well, you're going to get rid of all the mints anyway from kind of these properly, where in a greedy kind of way, you might as well get all the lowest characters, right? And then now, after that, it leaves you to some islands, right? Of like, okay, you remove the smallest number, and then an island, then now you kind of solve these islands, right? These islands will have its own thing, and then you solve them by, doing it recursively kind of. But of course, you can, and this would be a very natural idea, right? But you can't really do it this way easily because then, because it's very easy to construct a case. For example, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, dot dot dot, right? Where, okay, this is your first thing, and then you remove your island of your first, remove the first element as the smallest element. So then now you have n minus 1, n minus 2, n minus 3, dot dot dot. You have 1 plus 2 plus 3 plus dot 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 plus n is equal to n squared, right? Complexity, that's gonna be too slow. Right, so that's the thing that I was thinking of. So it took me a while to kind of come up with this, but the way that I don't know how I came up with it, to be frank. I just kind of was playing around with ideas in my mind and just kind of verifying it. But the way that I was thinking is that, okay, well, if you have, the way that I was kind of working forward backwards, right, is that, okay, if you have a list of, if you have an array, sorry, I didn't really draw the entire array, but let's say you have an array and this is your first move is taking the entire subarray, and then now, like I said, you're gonna leave yourself with islands because you're removing all the smallest number, and once you remove a smaller number, you cannot, it disconnects your subarray because then now these are zeros, right, in between, and if you go across 0, then you're wasting a move. Anyway, so you have something like this. And yeah, and then now the way that I thought about it is that, okay, well, within each of these, you're also removing the smallest number. So then now you have islands within islands, right? And maybe you have multiple of them as well, of course. I'm not going to draw the rest. And then now you have something like that, right? And then dot, dot, dot forward, right? Up to, you have, I don't know, one element or maybe even multiple elements of the same thing. So then now from this visualization, and that's honestly what I was thinking through my head, I was like, okay, this is, and a lot of solving problems is from practice, right? And what does practice buy you? Practice buys you, speed, of course, but also intuition. And for me, at this point, it just kind of feels, and I know that this is hand wavy, this is like, I don't know, right? But my point with these videos is to tell you how I solve them and not, like, I mean, if I just explain it to you and you're like, oh yeah, sure, but how do you actually come up with that, right? And sometimes there's a good strategy to come up with, but for me, sometimes, well, if you practice enough, you just kind of feel out the problem. And I kind of like have kind of made this visualization similar thing in my head to kind of as a proof, but that, if you think about this now, as a stack, you can see that here now you're going up the stack, and as you get bigger numbers, and then you go down the stack, and then go back up again as you go left to right, right? So kind of from that experience, I was like, okay, well, maybe I can just, something like that. I mean, I'm not drawing out precisely, but you get the idea. And from that, I was like, okay, maybe there is a stack solution because we do need either an O of n or O of n log n solution, right? And honestly, that's how I kind of came up with it. I just kind of had that visualization of like what we're doing here. And yeah, this is my stack, right? Basically, I just always start with 0 just so that the length will always be greater than 0. But yeah, the idea here is that, okay, when you see a bigger number coming through from going from left to right, well, what happens when you have a bigger number? Well, that means that your previous number is smaller, obviously, but that means that because of your bigger number, you're going to have to create a new subsegment, right? So that's kind of how I thought about it. If you kind of, I'm not going to bring up the drawing again, but you could see that if you have you have a segment that takes the entire array, and then now if you have a bigger number, you create a segment. And then that segment goes all the way to the right until what happens? Until you see a smaller number. So that's basically the property that I was dealing with, right? So if it's bigger, we add it to the stack, we add 1 because that's, you have to create one operation starting at this location. If it's equal, then great. We kind of keep going, right? We go to the next number by breaking, right? Also, yeah, if we create a new stack, we break, right? Because that means that you can extend that segment anyway, right? That's fine. And of course, if it's smaller, then you have to pop because that means that whatever you were doing, you have to remove it, and then now you have to do another count. Or well, in the well, yeah, stack will pop, and it pops possibly multiple times. That's why we have a while loop until we hit the not base case, but like which one goes the sentinel, which is then now you append x to create a new operation segment, if you will. And that's it. That's why I have this one. Yeah, and you can see that from here. This is linear time, linear space. I mean, coming up with this is tricky, but it's, you know, relatively okay to analyze, right? So stack, linear time, linear space, and that's it. That's all we have for this one. Let me know what you think. Thanks for watching, and you can watch me try to reason this during the contest now. And that's it. What do I expect? 6 and 3. Let's go. I mean, that should be, I don't know. Maybe I could be a little bit more careful, but if I get that wrong, maybe I don't deserve to do it. Okay. Nums and non-negative numbers. Operations that all numbers are 0. Okay. So you may select subarray and set all occurrences of the minimum non-negative. All occurrences of the minimum non-negative integer in that subarray to 0. Return the minimum. Okay. So you have 0, 2. So you select the 2 to 0. Okay, what is that? Okay, that doesn't explain anything though. 1, 3, 1, 2, 1, where the minimum non-negative number is 1. So don't we just always select it in order entire array? I'm confused. Right? Because you just do it always to the order array, right? When would you not? I think this is just like a silly problem. Oh wait, this is weird. Oh, I see. Maybe I'm because if you set them, then it becomes 0, and then you have to do the other ones one by one because you cannot use them if it overlaps with 0. I see. Okay, minimum not. Okay, I was so confused. I was like, isn't that just the length of the things? Okay, then how do I want to do it? I was gonna sort them because I didn't think it mattered, but now maybe I do. Do you always do one for all of them? I guess so. Well, okay, let's say. Okay, so it's almost like a divide and conquer thing. I guess you always do it for the entire way because you can cross boundary anyway in any of your operation. So you do it once, and then it just becomes recursive, kind of, I guess. But you have to be careful to not make it n square. Huh, this is a medium, huh? 4-pointer. Am I missing some obvious thing? Because usually I expect this to be much easier. The idea is that you can cross boundaries, right? But and the max will take the max anyway. Okay, so I mean, so you do them in order. I don't get how that's fast enough though. Am I just too dumb to realize a smarter way? Huh. So first is that minimum you always want to extend, and then the, okay. So I guess that is the way. How do we make it not n square? And without like, huh. Basically you save moves within each of them. But, huh, I don't know that. How did 3,000 people get this one? And I'm cheating a little bit by knowing that, because I maybe could not have known that, but okay, so you always do, I guess that's the only, I mean, the algorithm I feel like makes sense. I just don't know how to assimilate it fast enough for it not n square. Stack? Is there a stack based thing? Okay, so let's say we go from left to right. Okay, we have a 1. Okay. And that's only because it's in the beginning, but otherwise, okay, so what's the min? Can we, I mean, from left to right. If it's bigger, you push on the stack. If it's min, then you pop everything in between, right? Okay, maybe that's right. I don't know. Let's see, right? Okay, so length is stack is 0 to 0, then just stack that up and x, right? Otherwise, if it's bigger, okay, if it's bigger, maybe we just say 0, maybe that'll be helpful. Okay, so then now, if x is bigger than the top of the stack, then what happens? If it's bigger than the top of the stack, then yeah, you will late future do it, right? So here, okay, if it's equal to, then nothing happens because that's part of the current thing. So we continue. And then if it's lower, then now we keep on popping. Okay, maybe something like this. And then here we break, right? Here we also break. Otherwise, then if it's smaller, then we pop. because then now they're no longer connected, and then we go again until it's one of these two. Maybe something like that. 1, 3, 4. Not super confident about this. YOLO submit. Oh, okay. That one's kind of hard to work out. I don't know how so many people got it so fast. Good. Thanks for watching, everybody. Hit the like button, hit subscribe button, join me on Discord. Let me know what you think about this contest, this video, this problem, everything in between. Stay good, stay healthy, do good mental health. I'll see y'all later and take care. Bye-bye.